Alright, looks like we are live, guys. So, yeah, good morning. I was thinking what would be a better way to start my day than drinking my coffee and continue the last Codeforces Round editorial from where I've left off, right? Because I always keep my promises, guys. Of course, I have upsolved already these two problems, D and E, because they are super cool, and we are going to see how to solve them, right? So, first of all, quick mention: if you like these videos, hit subscribe. It's not that hard. If you like these videos and want more of these videos, hit like. Come on, it's not that hard. And also, a quick reminder, yesterday in the previous live, I have discussed problem C in like very broad details. So make sure you watch that live if you want to solve this problem C. If I have enough time, I'm gonna do a quick reminder of it. But we are focusing on problem D and problem E, which I started explaining in the previous live, but don't watch that, because now I'll take it from scratch and build it from zero and show you how I upsolved it. And of course, we can talk about problem B, why not? Maybe some of you are going to be excited about that too. So, you are 7, alright, that's pretty cool, because it's pretty early, so I didn't expect it to be a lot. But yeah, let's start with problem D, right? Because I haven't solved it yesterday. If you probably took part in this round, it's a very simple problem. For each of t test cases, which is at most 100, you are given basically 3 arrays, which are some gems, and you should choose exactly 1 gem from each of these 3 arrays, such that their cost, their, I don't know, difference, let's say, is as little as possible, and the difference is given by the formula. You basically take each pair of values and increase their difference squared, right? So let's take some example. Let's go into Photoshop, and I don't know if let's create something new, actually. Not open, create new. Yeah, let's create it. And yeah, all right, so let me do my setup real quick. I'm gonna choose color white, and the size is going to be 4. So yeah, what is this example? 7, 8, 6, 3. So let's see here, problem C, right? So as we saw, 3 arrays. Let's say the red gems were of values, as this example says, 7, 8, right? So 7 and 8. All right. The green ones are 6 and 3. Green ones are 6 and 3. And of course, the blue ones 3, 1, 4, right? So the blue ones are 3, 1, and 4. So perfect. Pick exactly 1 element from each of these arrays, such that if we pick X from here, Y from here, Z from here, right? You know the deal. X minus Y squared plus Z minus Y squared plus Z minus X squared is of course as little as possible, right? So let's say minimum. All right, great. We are ready to see how to solve this. Well, first of all, my line of thought was like this. All right, so 3 arrays, and I have this formula. Okay, let me think of some simpler problem first. Instead of this formula, it somehow reminds me, like, either I have X minus Y squared, or I have absolute value of X minus Y, they are pretty similar, aren't they? So first thing that I did actually is that instead of minimizing this formula, I wanted to pick the x, y, and z. Alright, this is absolute value, yeah, such that I minimize this formula with absolute values. Alright, let me see if this is a simpler problem. Well, it might be. Alright, furthermore, why am I thinking about this problem on 3 arrays instead of just doing this on 2 arrays at first, right? It should be simpler. So, let's suppose right, I start off by thinking about this. I am given basically 2 arrays. Let's call it A, with some values, A0, A1, A2, dot dot dot, some A of n minus 1, so this has n elements, and another array, let's call it B, yeah, which again, B0, B1, dot dot dot. Let's say this B array has m elements, so all the way to B of m minus 1, and all I have to do is pick 2 elements, one which will call x from this array and another one which will call y from this array, such that their absolute value of the difference, their absolute difference, is minimum. Yeah, alright, this is really simple, right? So I would say it's kind of classic, because in order to solve this problem linearly, of course I can't pick, like, I can't fix each and every possible x and each and every possible y, because I will have big O of n crossed m. So I can choose one of them. Let's say x. I can fix this x, which is going to be each value inside the A array, right? So let me say here that I'm gonna say for each and every value x which is inside this array A, okay? And if I know the value of x, let's just say is this one, for example. Of course, brute force approach, as we said, we try each and every y. But we are smarter than that. Why trying each and every y when we know there are only 2 possible y's that can give me this minimum absolute difference? And those are the smallest element in this array, which is greater or equal than x, and the greatest element in this array, which is smaller than x. So, again, let me write this here. So let's say, alright, let's say here, just to look a little bit better, let's say we have some element x, right, which we've picked, then some elements a of n minus 1, and the problem is for each and every x, right? So among all these values, when I want absolute difference, I only care about the smallest, right, which is greater or equal than x, or the greatest, which is less than x. So how am I going to know those values really quick? If this array is unsorted, right, so their elements are kind of shuffled or random, I won't know them quick because I have to iterate each time in linear time. So one smart thing to do is always sort these arrays first. I'm going to sort array A and sort array B initially. So first thing I'm gonna do is not fixing X, but sort A and B, right? And let's say we sort them increasingly. So we sort A and B. Let me do that because, okay, the sun was really annoying. So we are sorting, it's still annoying. All right, yeah, hope you see me well now, everything's great. So yeah, we are sorting A and B, right? And after sorting them, I'm gonna fix this X, and I can find those two values that I look for, either binary searching or two pointers technique. It's really your choice, right? So for each X which is part of A, right? As I said, your choice. You can do binary search, you can do two pointers technique. The idea is that you will quickly know those values and you are trying both of them, of course, and take the minimum absolute difference. You do this for each X inside this array and take the minimum from all these answers for each and every X. Perfect. So I managed to solve the simpler problem in big O of n log n, right? Because I sort these arrays. Alright, so I think I might be ready to solve this problem still with the absolute differences, but on free arrays. Let's think about that. So let's say here, right, we are having now free arrays. So here is the third array, let's call it C, right? And let's say this array has so n, m, and I don't know, maybe q elements, who knows, right? All right, so I have now x, y, and z, right? Pick x from here, y from here, z from here. Great. Well, brute force approach, big O of n cube. Try out each and every possible x, y, and z. Another brute force approach, try out each every possible x and y, and then the z is quite simple to compute. But in order to perform this in linear time, again, I have to limit myself to only one of them, right? So I can either fix what is going to be the x, or what is going to be the y, or what is going to be z. Great. First of all, as we have noticed on the previous problem, it is always useful to sort these arrays. But I'm going to take this to the next level, because not only that I want to have the elements in array A sorted, and those in B and those in C, I want to have all these values, all of them, sorted in one bigger array, because I am interested in the order of them when they are all of them in the same collection or array, right? So first thing that I'm doing is that I'm going to create another array, let's call it D, which is going to be consisting of all the elements in these three arrays, A plus B plus C. Then I'm going to sort this D, and now I have each and every gem increasingly sorted in one greater array. And let's see how this is gonna help me. Well, let's say we take some example. Let's say we take even this example, right? So if I have this example, right, and again, let's change these names because I don't really like them. So let's just call this A, let's call this B, and let's call this C, right? Then the array D, after merging and sorting, is going to consist of 1, 3, 3, 4. So 1, 3, 3, 4, 1, 3, 3, 4, 6, 7, 8, right? 6, 7, 8. Another important thing is that I want to know for each of these values from which array it belongs. So this D is actually an array of pairs, where the first argument in the pair is the actual value, and the second one, let's say, is the array where I've taken the element from, right? So in the case of 1, I can have some index, let's say. So if it's part of A, it's 0 in its index, its second argument, okay? If it's part of B, it's 1. If it's part of C, it's 2, right? So this is a 2, right? This 3 is taken part still of 2, let's say. This 3 is from that's 3 actually, sorry, my mistake, yeah. So 3, 3, 2, 3, 3, 3, 2, 4 is part again of 3. Alright, this is from the second one, and these 2 are from the first one, right? So now you've probably got an idea of how this array D looks like. Great. Now, instead of picking X from A, Y from B, and Z from C, we are going to pick all of them from D. But the restriction is that X has to be of index 1, Y of index 2, and Z of index 3, right? So what I'll basically do here is that I'm not gonna know for sure, let's say, who's X, who's Y, who's Z, right? So I don't, let's say, I pick this position, right? This is a 1, so yeah, I'll basically know that this is going to be my X, right? But it doesn't really matter. All that matters are the values, right? So anyways, I'll basically pick 3 elements from this new array, such that these little indices, which mean where they came from, should be all different, right? So I can pick, let's say, the answer for this problem, if I'm not wrong, I think it is 3, 4, and 7. Yeah. So if, let's say, the answer here was 3, 4, and 7, right? 3, 4, and 7. Yeah. On this new merged array, I will have 7 from the first one. I will have 3 from the second one, so here, and of course I will have 4 from the third one, right? So what I basically did here is that I've picked 3 elements. All of them, as you see, have different indices, 2, 3, and 1, very important, and their values is as little as possible. Now, on the problem that we said that it's gonna be a little bit simpler, which is with the absolute differences, it's quite straightforward, right? I am going to fix each and every last element, right? So you can see this as 3 elements, D of I, D of J, and D of K, with I less than J less than K. I'm basically fixing each and every K, right? So for each and every K, let's erase this. What I'll do here is that for each and every K, for each K in the range, basically starting at position 0 all the way to position, yeah, whatever, something like n plus m plus k minus 1, right? M plus that was q, the size of the third array. You got a whole idea, right? So for each of these case, right, in which I fix this kind of element, what I'll do is that I'll take a look at its position, and what I know is that I have to choose 2 more with different indices here such that that cost is minimum. So if this color 1, let's say color 1 or index 1, if this color 1 is 1, right, color 2 and color 3 have to be different. So what I'll basically do here is that I am interested to find out, like, what is the first element on my left which has the other color, and what is the first element to my left again which has, of course, the third missing color, right? So the second and the third missing colors, what are the elements, the first elements on my left which have that? Because I kind of have an intuition that those are going to be part of my answer, and they are, you'll see. So if let's say let's call C1 to be this color of K, right? So color of that one, and of course let's call C2 and C3 the two missing colors, da? Yeah. That was yes in Romania. So the other two missing colors. All right, perfect. So I need one more C2 and one more C3, right? Yeah. So first one to the left, C2, first one to the left, C3. So let's say, I don't know, P2 is the first to left, and we are going to dive into the implementation of this, so don't worry, you'll understand then. First of left of C2, and P3, yeah, that boundary, I hate that. P3 is the same, but of course for color 3, right? So after I find P2, this is going to be P2, this is going to be P3. What happens is that I basically am going to know my elements in D, which are going to be my solution, right? So my solution are going to be P3, P2, and K. How do I quickly know P2 and P3? Well, it's super simple, because I iterate on array D starting from left and going to right. I can store another array which is going to tell me what was the last position where you've seen color 0 or color 1, what was the last position where you've seen the color 2, and what was the last position where you've seen the color 3. So we are basically holding here 3 variables, right? For each color, the last position where you have seen that color. And of course, if I know the color, I take the other 2's, I know the positions, I make the minimum, and here you got your answer. Why is this the answer? Well, I think it's pretty obvious. Because when you have this array D, which is increasingly sorted, right? So let me do a couple of cleaning here. Yeah, you have this array which is increasingly sorted, right? Well, I think it's pretty obvious that if you fix this last element on your tuple and you found out, alright, so if this is my last element, basically for this example, right, are you sure this was a 1? Yeah, I guess so it was. Yeah, it was a 1. Yeah, okay. If this was a 1, basically this was a 3 and this was a 2. Yeah, well, if this was a 1, for this example actually, this would have been the pair. But yeah, it doesn't really matter right now. So this would have been the pair, right? So if I choose the pair, it's pretty obvious that first of all, you will have, like, best case scenario, this 3. Because if let's say the other 2's were not here and were somewhere like here and here, whatever, right? Well, if basically this is the range in which you first encounter the other two colors, you can't compress the range to something like this one, right? Because you won't have the three colors, right? So it's not a valid configuration. And of course, let's get back to our example here. After we know what are these three, right? The one we fixed, the first one with the second missing color and the third one with the other missing color, there's no point in moving this arrow to the left, right? Because if, let's say, these values are A, B, and C, right? So C is this value, D of K. B is this D of J, or whatever it's called, and A is this D of I. If I know these three values, remember, we are thinking about the problem with the absolute differences. Yeah, I have this absolute difference plus this absolute difference plus this bigger absolute difference, which is indeed 2 times this bigger absolute difference. So of course, if I move to the left, I increase this absolute difference, so it's gonna be a greater solution, which means also a worse solution, right? So yeah, why did I solve this problem with absolute differences? Because it is very similar for the actual cost with the squared sum, right? Well, how is it different? Really simple. Let's take this general T, right? So again, merge those three. We know the pairs, right? We also know the indices. And yeah, this is m plus q minus 1, right? Great. Well, simple. Exactly the same solution. Exactly the same one. Fix the last element, which is going to be that D of K, right? He has a color. Let's suppose its color is 1, for example, right? So I know this value, D of K, its color is 1. Find the first color of 2 to its left. Let's say it's this one, just for the sake of example. Find the first color of 1 to its left. Let's say is this one, right? So that's, let's say, color 2, D of 2 with color 2, and D of 1 with color 3, right? Well, first of all, because now you have those things squared, right? So you have something like, your formula is going to be something like D of K minus D of J, everything squared, plus D of J minus D of I, everything squared, plus D of K minus D of I, everything squared. As you know, this function, the squared, right, gets bigger and bigger, greater and greater pretty quick. So, of course, D of I is less than D of J, less or equal, which is less or equal than D of K. So this is the greatest value. D of K minus D of Y is the greatest difference, right? And if we increase this difference squared is going to increase itself way more significant than those ones too, right? So your intuition is already, alright, so I really should be careful about this difference, which is the greatest one, right? Because if I do something like K is fixed, alright, I know this, but if I take this number and move it to the left, right, and make it less, this is going to get big pretty quick and significant. So I don't want that. So when I fix D of K I found out first on the left with some color, first on the left with the other color, right? The minimum position between these two is d of I. This is going to hold still, not moving to the left, and of course not moving to the right, because the configuration won't be valid. So d of k, I know it. D of I know it. It's constant now. I have to choose d of j such that this cost is as little as possible. Yeah, so this became constant after finding out what is the value of I, right? And now, for these ones, you can imagine that on the number axis, somewhere here is d of k, right? Then a little value, a smaller value, is somewhere here d of I, right? And you basically have some possible points where to fix your d of j. So where should you do it? Where is the optimal place to fix this d of j such that this sum of squared differences is as small as possible? Yeah. The optimal scenario is to choose d of j to be in the middle of this range. So to be d of I plus d of k divided by 2. Like, this is the best case scenario. Very simple mathematical proof, very intuitive. The best case scenario is to choose d of j to be right the middle of this range. If you can do that, that is awesome. But you might not do that. So you want this d of j to be as close as possible. It can either be greater or be less, but you want it to be as close as possible to this middle of the range. So, what I'll do? How will I find, again, quick, the closest value d of j as possible to the middle of the range? Well, that calls for a binary search too, because remember, I sort everything at first. So, summary here. Very, very brief and simple summary. Then we are getting into the coding part. Right? Great. Build D, which is the merging of these ones. Of course, sort D afterwards. Step number 2. Fix that K, that last element from D. Fix that K. So we know basically D of K and because we store where that value came from, also its color, right? We will call it color, which is of course either 1 to 3 or 0, 1, 2. You can zero index the colors if you want. I did that during the contest. So yeah. So we know D of K, the value, and its color. Then find the 2 missing colors from those 3. So if this is 3, find the first one, the first thing colored in 1 to the left and the first thing colored in 2 to the left, and take those minimum. So that position I is the minimum between last value or color, we can call it color, I think it's more accurate, last color of the other one, C1, which is missing, and of course last color of the other one missing, which is C2. Great, awesome. I know K, I know I. We have proven that I is going to hold still. There's no point in moving it to the left. So I just need to find J. First of all, find what is going to be the color of J, right? Super important. So color of J, which is basically 1 plus 2 plus 3, 6 minus this color, right? color of k minus color of I. And now, after finding this color of j, I should take a look in that array and find me a value as close as possible to this d of k. So d of k plus d of I divided by 2. Find me something as close as possible to this value in the array specific to color j, right? In that array. So, in an array, find me a value as close as possible to some other value. Of course, binary search. So not only we build and sort D, we will also sort these three arrays too. Fix K, find out I, find the color of J, go into that array which is sorted and binary search the smallest, the least value greater or equal than this one and the greatest value less than this one. Basically the upper bound, the lower bound and the lower bound minus 1, right? And take the best out of these two. And that's it. Alright guys. I don't know how many are you out there. Alright. You are a couple of them. Alright, perfect. I think your audio is not working. Really? Or it might be slow. No, it's working. I hear myself well, so yeah, maybe increase it a little bit, so that's cool. Yeah, alright guys, so yeah, if I take a look at this submission, it's gonna be exactly what I said, right? So for each of these three arrays, yeah, pretty quick, right? In all gems, which is that D, I have the pairs x and 0, x and 1, x and 2, and in gem 0, gems 1, gems 2, I have the separate arrays A, B, and C. Sort each and every of those three arrays, sort the D, right, the greater array, and then here I've called it I instead of K, right? Fix that last gem, that last element in D, find its color, find the minimum between last gem, so last color of color plus 1 and color plus 2 divided by modulo 3, yeah, and that is going to be, as I called it in my drawing here, K and I, and then find the color of the missing one, which I called Y color, perform a lower bound on its vector, and x plus z divided by 2. This is sorted, so this is all great, and then I have a couple of cases, right? If I don't have any element greater or equal than it, I'm gonna take the greatest one. If all the elements are greater or equal than it, I'm gonna take the first one. And if I get to choose, I'm gonna take the least value greater or equal than that value, and the greatest value strictly less than that value, and of course take the best out of them. If y1 is greater than y2, is better than y2, take y1, else take y2. Take this value, this final value, after I know the optimal j for this I and k, and update the answer. That's it. Of course, time complexity big O of n log n from the sorting. Hope everything's more clear now, right? So yeah, great doing. Alright guys, thanks for appreciation. Alright, we are going to move a little bit faster in order to solve also problem E. So yeah, I think that was D actually. Yeah, this was D, not C, sorry. So just a quick reminder again guys, if you wanna see me solving problem C, you just have to go to the channel and watch the previous live as I solve this in super great detail. Now, moving on to problem E, which was indeed pretty interesting too. So problem E, again, I have some string S, right, which in this example is A, B, A, B, A, B, A, B, and some string t, which is BA for this example. Yeah. What does this problem say? Basically, is that we start off with an empty array, let's call it A. This is initially empty, and we are iterating through all the characters in S. I mean, not all of them. There's actually not all of them. Yeah, that's right. We basically can perform between 0, yeah, and n moves, where n is the length of S, because yeah, I can't perform more than n moves. And at one move, what will I do? I will remove the first character from S, and I can have, let's call it some left move. That character that I have just removed, I will insert it to the front of A, so front of A, or I can have a right move. That character that I've just removed from S, the first one, I'm gonna move to the back of A, right? Just like A is a double Q or something. So I have to count how many possible ways are there of performing such moves. Again, between 0 and n moves of left or right, in order to build some string A which has the first m character. So let's say this length of t is m and this length of s is n. Have the first m characters, right, the prefix of length m, exactly equal to this string t. This was the question. And if you was live with me yesterday during that live, you would know that basically what happens here, yeah, is that the problem is with these left moves, right? Because if I only had right moves, that's pretty obvious that each time I perform another move, I just take the character and okay, A, yeah, right move, this is A. B, yeah, right move, push it to the back. A, yeah, right move, push it to the front. But because I have also left moves, I can perform here, for example, some left move and push this B to the front of A, right? So this becomes BA, 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 right? So yeah. All right. Basically, the most basic thing that you can notice here on this problem is that each configuration, each answer to the problem that we have to count is an array of left and right, left, left, and right, of length less or equal than n, right? I can simply, let's say, for each left move that I perform, I can write on my paper some L. For each right move that I perform, I can write on my paper some R. So I'm gonna end up with a string of L's and R's, at most n of them, such that, very careful, I need this prefix to be part of my final string A. Okay, so my first thought here was really simple. I have two strings. I have n, which was something like less or equal than 3000, yeah? Just take a look at n, is less or equal than 3000. So it was pretty sure to me that, yeah, some dp on strings, which is still big O of n squared, right? So, some dp on strings, big O of n squared. Cool. Let's do this. What are some possible scenarios for my dp? Well, first one is that my dp of I and j could mean something like this. During the contest I was like, alright, this is s, yeah, so s0 s1 dot 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 s of n minus 1, and this is t, right, t0 t1 dot 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 t of m minus 1. So during the contest I was like, dp of I and j, alright, should be something like this I is going to mean the first I characters here, I'm pretty sure of that, so the first I characters here, and this j could mean something like the first j characters here, right? This is the most basic dynamic programming on strings, right? So let's say something like dp of I and j, in how many ways I can perform exactly I moves, right? So basically I moves mean that I perform moves on each and every of this s0, 1, I minus 1, right? Exactly I moves, such that that string A that I'm gonna obtain after performing all these moves has the prefix of length j, right, matching these first j characters, right? Or in other terms, you can call the LCP, the longest common prefix between A and G and T, is going to be of length j. So this is j minus 1, right? Yeah. All right, pretty cool. So that was my first thought, but that failed. And why does this fail? Is that, of course, when I want to compute dp of I and j, right? So I am basically wondering what I'm gonna do with s of I minus 1. Oh, I hate these boundaries. Anyways, sorry about that. So yeah, so I'm wondering what I'm gonna do with s of I minus 1. The problem indeed is that if I choose this last move with s of I minus 1 to be a left move, so to push this at the front of my string A, I don't know what's going to be my j, my next j, right? Does it make sense? So I know what is dp of I and j, right? Let's say I already know this value and I want to go and update some dp of I plus 1, right? So basically I'm updating other dynamics, other values of the dynamic programming, right? So if I, let's say, was here s of I minus 1, right? So my dp basically performed all these moves, and now I want to move to s of I, right? S of I to perform this I plus 1 operation. If I choose this to be a left operation, what was my A, right? Because after this dp of I and j, I have some corresponding A, right? I have some A, which, as I know, has the prefix of j matching the prefix in t, so t0, t1, t of j minus 1. And then, of course, it has its own values, right? A of j plus 1, dot, 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 dot. Perfect. Well, when I have this element to be pushed to the front of A, this is the problem, because I don't know what this j is going to be, right? Because, okay, I can check if this s of I is equal to t of 0, so at least the first character in A is gonna match the first character in T, but then I don't know about this ones, which is going to match one position to the right, how is going to be equal to the T, which this time starts from position 1. Alright? So, as I said in my previous live, it's really easy when I want this next move to be a right move. right? Because that's going to be my last element, and it's really easy to compare this last element with the next one in T. If they are different, J remains the same. If they are not different or equal, J increases by 1. That's super simple. But when I choose this to be a left move, I have no control over what's going to be my next J here, right? Because again, if those two are equal, I have to compare now this first J with this one starting from T of 1. And it's quite hard. So then I knew that that's not going to be my solution. And the solution is even simpler than that. Because, as I said in that live, I started thinking about this kind of scenario. S0, S1, S2, dot, 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 S of n minus 1, let's say, right? And let's say my answer is, again, a couple of L's and R's, right? Let's take a couple of them. For example, I don't know, L, R, R, L, R, L, R, right? So for this particular example, I have n to be exactly 7, right? So S0, S1, S2, let's write it S3, S4, S5, S6, yeah? So let's take a look at what happens here. Well, S0, left move, alright, S0, perfect. S1, right move, alright, S1. S2, right move, alright, S2. S3, left move, alright, S3, right, left move. Now, S4, right move, okay. S5, left move, okay. So S5, that's the A. And of course S6, right move. So what I've noticed basically is that if I iterate from left to right, when I encounter some left move, it's quite hard to get that character and move it again to left. But then I've noticed one amazing thing. If I know this sequence of L's and R's, I know for sure that if I take a look of what is the last left move, for example, it's 0, 1, 2, 3, 4, 5, I know for sure that its corresponding element, character, is going to be the first one of A, right? So last L, let's index this, 0, 1, 2, 3, 3, 4, 5, 6, right? Last L, position 5, first element, S5. I might be onto something here. Then, the one before the last, on position 3, second element in the final string, S of 3. The next L, taken from right to left, 0, the next element, S of 0. So, I can iterate from right to left, and each time I encounter some left move, that's going to be pushed to the back of the array. And then, what will I do with these right moves? Well, from left to right now, in their order, first one is 1, S1, then 2, S2, then 4, S4, then 6, S6. So what I've basically noticed here is that what I have to do is take my sequence of left, rights, dot, 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 left, rights, and my final string is going to consist of taken from right to left, each and every left, then taken from left to right, each and every right. That's going to be my final string. So I can perform some dynamic programming more easily with this kind of approach, iterating from right to left. And this was the key of the problem. The key of the problem was iterating in reversed order. Great. And let's see how to solve it now. Pretty easy, guys. Pretty easy. Pretty easy. Now, because I iterate from right to left, my dp is going to be dp of I. Not the first I moves, but indeed, and be very careful here, some moves that end here. So if this is I, you might say, alright, I perform all these moves, right, from right to left. But it's not all of them. Because, as I mentioned in the previous live, you don't necessarily do all the moves. You have to perform at most n moves. So yeah, could end something like here, or here, or here. But there's no problem. You know that when you iterate on this string from right to left, you either don't make any move, or when you start making moves, right, left, you're going to continue making moves until the first character, right? So, dp of I is from iterating from right to left, you get to this position I, right? So to this character s of I, and you have performed all the moves, all these moves, where again, taking into consideration that you can perform no move at all for some suffix, and of course j, what should be the j? J should be the number of left moves. Because if I know for this I by now how many left moves I have performed, left, let's say I have performed 4 moves, when I move to the next I minus 1, I know that if I choose this to be left, I know this s of I minus 1 is initially going to be on position 5 on that A. Remember, from right to left, every L is pushed to the back of A. So if I have 4 L's here, and I choose this to be an L2, this is going to be the 5th element in the final A string. And that's it. And that is exactly what I want. I want dp of I and j in how many ways I can execute or non-execute, right? So execute, or for some suffix as we've seen, non-execute, right? Moves in the range from I to n minus 1, and I have performed, this is great, I have performed exactly j, right? Exactly j, L or left moves or operations. And that's it, guys. That is it. If I know dp of I and j, the recurrence relation is going to be pretty easy. Because as I told you, I have performed all these moves or not performed until here. So what I have to do is go to I minus 1 and update that dp. So I basically have 2 possible cases, as you know. If I move to dp of I minus 1, the first scenario is if I choose this move to be a left one. What's going to happen? Well, the number of left moves is going to increase by 1. So dp of I minus 1 and j plus 1, right, is going to be increased by dp of I and j. Of course, when you can perform a left move with this I minus 1, what does this mean? Because this character, as we said, is going to be So here I have j left moves. This is going to be the j plus 1th left move. So this is going to be the j plus 1th character in the final A string. So I have really to make sure that either this j plus 1 is greater than m, or t of j plus 1 is equal with this s of I minus 1, right? So either this character, the j plus 1th, surpassed the m first character, so it doesn't really matter its value, or if it didn't and it takes part into that prefix of length m, you really have to make sure that it's going to have the right value. Otherwise you won't have the final prefix of being the right one. And for the second test case, for the second scenario, it's exactly the same thing. You'll have a dp of I minus 1 and j. Why does it that? J, because you now choose this one to be a right move. And if this one is a right move, again, I'm just going to increase it by dp of I and j. And here was the trick. If this one is a right move, let's think. I have here exactly j left moves. So I know these j left moves are going to be my first j characters. Then, when I'm getting into this prefix, exactly into this position I minus 1, it doesn't really matter if this is an L or an R or an L or an R and so on and so forth, because whether if these elements on my left are left moves or right moves, they are anyways going to stand in front of me on the final A string. So the key observation here is that if I have this I minus 1 to be a right move, I also know its position, and it's going to be j, because they are always going to be the first j characters, plus I minus 1, because I'm going to be the last one from this prefix. So j plus I minus 1. Again, very similar to this one. If j plus I minus 1 is greater than m, or t of that is equal to s of I minus 1, I can increase it. In the end, what's going to be the answer? Well, the answer is dp of 1, so that you have iterated through each and every character here, right? And you can have how many left moves you like. 0, 1, 2, dot, dot, dot. Of course, all the way to m moves. You take the sum of these dp's, and this is exactly your answer. Time and memory complexity, guys, big O of n cross n. And that's amazing. Right, we can take a look at some code if you're still with me. So yeah, all right, hope you've all understood the E problem. Yeah, in the left ear, I think you don't hear. I know why you don't hear me. Yeah, because I have this microphone and its default setting is on stereo, I think, and I have to set it to mono such that you can hear me in both ears. I know, quite strange, but that's it. Yeah, and in the previous live I've also showed you my source code. It's super simple. It's just dp. I initialize those dp's, and as I've told you, I iterate from right to left through the string. J is the number of left moves, and I say, if you're gonna be a left move, check if you're valid and increase dp of I minus 1 j plus 1 with dp of I and j. If you're gonna be a right move, check if you're valid and increase it with dp of I minus 1 and j with dp of I and j. At the end, take all these values into my answer. And that's it, guys. I really hope that you've understood it. So we have solved D, we have solved E. Again, another reminder, we have solved C during the previous live, so make sure you go there. And for B, I don't think there's much to tell about B. It was a quite simple, greedy approach. I think most of you got it. The thing is simple. If this H is greater or equal than 20, this operation is not doing much, because no, if it is, sorry, less or equal than 20, this is not doing much, because it can only, worst case, increase your value but not decrease the value, right? So yeah, what I basically did here is that for all of these n operations, and as long as h is greater or equal than 20, is greater than 20, sorry, I have just performed the first one, and then I checked if m crossed 10, right, is greater or equal than my remaining value, and then I can do it. So yeah, B was pretty easy. This is what I did when upsolving this, right? So just simple as that. As long as I have operations of the first kind and x is greater than 20, perform the first one and then check this. Of course, during the contest I've computed some very, very nasty dynamic programming, but it was pretty fun. So yeah, no regrets about that, for sure. So yeah guys, this was it. Thanks a lot for being here. Thanks a lot for solving these problems with me during the coffee time in the morning. And of course, again, call to action. Please guys, your support is really needed and is really appreciated. If you like this kind of videos, hit the like button. Come on, it's not that hard. If you like the channel and want more, hit the subscribe button. Join the party. Come on, it's not that hard. And of course, as always, let's move and increase the rating, because as you know, my rating was on a downfall even after this round, which yeah, was better than the last ones but not great. I'm still a lot behind. We are going to document the journey of surpassing my my previous historic maximum rating, and why not even get on the new orange or something. But it's gonna be a long journey, so stick with me, subscribe, become an Algopedian, and I'll see you on the next rounds and on the next live videos, right? This was Andy, over and out. Bye guys, have a great time, solve as many problems as you can, and I'll see you on the next one.